All right, students, we are continuing our transformation unit, and today we are going to focus on a type of transformation called rotation. The first vocab word that we're going to talk about is where does the shape rotate around? How do we rotate a shape? The definition here says a point in which a figure is rotated. So this point right here that this arrow is pointing to, this is an arrow, so the origin, that in this particular picture, this figure is being rotated around the origin. So think like a record, and here, that's where you put your pencil to keep it there, and then you would spin the paper around. So that's the place where the shape is rotating around. So we call that, so this right here is called the center of rotation. It's the center of rotation. Okay, and then this one, an angle formed by rays drawn from the center of rotation to the corresponding vertices of the figure and its image. So here you will see that here's the center of rotation, and there's a segment drawn from the center to the vertice, and there's one here from the center to the vertice, and it's the same vertice, the corresponding vertice. Well, this angle here that's formed, we call that the angle of rotation. Okay, angle of rotation. Alright, so you can actually just graph a picture, rotate it, turn it, list the new coordinates, or you can memorize these rules here. If a shape is rotated counterclockwise, now remember, clockwise if this is my clock, this is 12 o'clock, there's 6, there's 3, and 9. Clockwise goes this direction. So CW stands for clockwise. Counterclockwise okay, so we have the same clock, 12, 6, 3, and 9. Counterclockwise, it goes backwards. Okay, and you'll see that as CCW, counterclockwise. Okay, so here, if we have a point and it is rotated counterclockwise about the origin, then that point AB, the rule is that you take the two and you switch them, and then you change the sign of the first one. So the B would go here, the A would go here, and this would become a negative B. So you would change, if it was a negative, you make it positive. If it's positive, you make it negative. But you change the sign of this one. Alright, now, if that same point is rotated counterclockwise about the origin, and its rotation is 180 degrees, so that's like 2 quarter turns, then the rule is that you keep the A and the B in the same location, but you're going to change both of the signs. So this one would become negative A, and this would become negative B. Alright, the next one, if you take that same point and you rotate it counterclockwise about the origin for a rotation of 270, then that is, the rule on that one is you're going to change them, exchange the A and the B. So the B would go here, and the A would go here, and then you would change the sign of the second one, A. Alright, so here, I just want to make sure that you know that what I'm talking about, a rotation of 90 degrees. So let's say, here's my point A. If I rotate it 90 degrees counterclockwise, this is 90 degrees counterclockwise, that means I'm turning it over. It'll go from the first quadrant, and it will turn into the second quadrant. If I have a shape or a point that's going from the first quadrant, and I'm going to turn it counterclockwise 180. It's going to turn 90 and then 90 for a total of 180 degrees counterclockwise. So it's going to turn all the way over here to the third quadrant. And 270, if I start here, and this is going to be in quadrant 1, then it's going to be 90, 90, and 90. This is going to be a 270 degree counterclockwise turn. So it will end up in quadrant 4. Okay, here, when we rotate a figure, this theorem states that a rotation is isometry, which means that the two triangles are going to be congruent. So I'm going to highlight this. This is congruent. And just make a note to yourself that the triangles remain congruent. All right, next. All right, so the next page, you are starting our examples. You're going to need a protractor to use as a straight edge, and you need a protractor because we need to measure the degrees. Okay, draw a 150 degree rotation about point P of triangle ABC. So we're going to, there's our point of rotation. Notice how it's not the origin. It's around this point. So this is where I would turn it, and I need to turn it, starting here, I need to turn it 150 degrees. So this is how you do that. You start off by drawing a segment between point P and one of the vertices. So I'm going to start here with A. And I'm going to draw segment AP. Right? And then from segment AP, I'm going to line up, put this on point P, and I'm going to line up the bottom of my protractor so that it's in line with AP. Now I'm going to create an angle. So this is 0 degrees, 10, 20, 30, 40. It's opening up all the way over around to 150, which is about right there. So here, this purple angle that I'm drawing right now, this is a 150 degree angle. Okay, so this purple segment AP is the distance between the origin, or the center of rotation, and the vertice. So you need to measure that. All right, that's about 1 and a little more. 1 and just a tiny little bit. So I'm going to go over here and measure that same distance. 1 and a tiny little bit is right here. So that's where point A is. This right here, this segment right here, is this segment that's been turned 150 degrees. And this is A prime. So we'll mark that, we'll label that point in just a minute after we get all the rest of them drawn. The next one is going to be BP. So here's this one. Do the same thing. I'm going to put my point here, line it up with the green line, then start over here, go around to 150, and I'm creating this 150 degree angle. Okay, just kind of lightly draw it all the way out. But then I measure how far is it away from the vertice to the center of rotation, and it's going to be a 1/2 of an inch, and then 1, 2. So for me, that's going to be here, 1, 2. So about right there. That's this here, but that's B prime. Okay, next we have point C. All right, so I'm going to connect them. Then I'm going to create an angle, 150-degree angle all the way over, about right there. Draw my angle, then measure the distance away, and it is exactly, well, just a little shy of 1 inch. So here, just a little shy of 1 inch will be about right there. So there's the distance away. All right, so to draw my triangle, this right here is A prime, this is B prime, and this is C prime. So I'm going to connect, draw a segment. And remember, this is my transformation. So this is the dotted, this is the image. Okay, and then we have this one. So I'm going to make it dotted to show you that this is the pre-image, there's the image. Okay, and so here's the right angle, so we're going to mark this one with a right angle also. Here's your right angle. And so here it has turned 150 degrees. Alright, so now what we can do on this next one, it says graph this using the vertices, then rotate it about the origin, then list the points. Okay, so that's one way of doing this. There's the other way from your notes is the rules. Right here are the rules from page 1. We want 270 rotated 270 about the origin. Okay, so 270, it doesn't tell you which direction, so this is going to be, I'm going to choose counterclockwise because I have the rules for this. So counterclockwise. The rule is that if I have x, y, then, and I turn it 270, then I switch them. So this becomes that's y, and this is x, but then I change the sign of the second one. Okay, so that means that I'm going to list my points, K, L, M, and N. K is going to be at 3, 2. L is going to be at 4, 2. M is going to be at 4, negative 3. And N is at 2, negative 1. So now I transform them using my rule. So switch them, 2 and 3, and make the second one negative. Change the sign of the second one. Switch, it's 2, and change the sign of the second one. Switch, change the sign of the second one. And switch, changing the sign of the second one. So these are my, this is K prime, this is L prime, this is M prime, and this is N prime. Okay, to check it, what I want to do is graph this. So this is going to be 3, 2, 4, 2, 4, negative 3, and 2, negative 1. So we're talking about this shape right here, this quadrilateral, K, L, M, N. I'm going to shade it in so you can see it a little better. We're talking about that quadrilateral. We want to turn it about the origin, so if you look at point L, we want point L to go 1, 2, 3. Point L should be down here. So turn it 1, 2, 3. Okay, so now if this is the first quadrant, this is the fourth quadrant, you know that L should now be at 1, 2, negative 1, 2, 3, 4. So L prime should be at, if you look at L prime, should be at 2, negative 4. 2, negative 4, and it is. So that's how you check your work. All right, then it says, write the matrix that best represents the image. The image is after it's been changed. So remember, that's going to be the K, the L, the M, the N. We put the X's on top and the Y's on bottom. So this is going to be 2, negative 3, 2, negative 4, negative 3, negative 4, and negative 1, negative 2. All right, so that's your K prime, L prime, M prime, and N prime. And remember, this part up here is not necessary. This is the answer. All right, folks. Next, I have a quadrilateral that is rotated around P. I need to find the value of, this should say X and Y, so change it, X and Y, then find the perimeter of the image. Of course, I'm going to use color to help me with this one, to help me keep track of the sides. So here, this blue side right here maps to this blue side over here. This pink side is this pink side. See, pink then blue, pink then blue. And then the short one, that's going to be this one here. It's going to be this side here. And then this side and this side. Okay, so here I'm going to start with the yellow one because that's the last one I drew. Yellow is congruent to yellow because it's isometric. So I'm going to say 3x equals 6. Well, if 3x equals 6, then I divide both sides by 3. So I know that x is equal to 2. Okay? Next, I'm going to put down the pink one. The pink one says that 3x plus 1 is equal to 7y. Well, I know x is 2, so I plug that in. That's going to be 3 times 2 plus 1 equals 7y. 6 plus 1 equals 7y. 7 equals 7y. Divide both sides by 7. I get y equals 1. So I found my x and my y. Now I need to find the perimeter. Okay, well, the green side equals the green side. So I know this is 4. I know this is 3. I know this is 6. And then here, I know that y is 1. So 7 times 1 equals 7. So I know this is 7. So to find my perimeter, I need to add the 7 plus the 4 plus the 3 plus the 6. 4 and 6, that makes 10. 7 and 3 makes 10. 10 plus 10 is 20, so the perimeter is 20. So I found my x, I found my y, and I found my perimeter, and this is units. And that's it for the examples. Notice how your check for understanding looks exactly like the examples. And here, you can use this graph. It's provided so that you can check your work. So I do expect to see the graph filled out. So make sure that you use a compass and use a straight edge. Make sure that you're listing the points, drawing your matrix, graphing it. And then here, it's easier if you color code it or mark it in some way. So make sure you have this completely filled out before you come to class next class period. And that is it for notes 9.4.